All right, so in 4.1, we're going to talk about graphing polynomial functions. In 4.2, we're going to talk about adding, subtracting, and multiplying. And then 4.3 gets its own lesson for dividing. Okay, so we'll review over long division of numbers before we do that. So in this first lesson, we're going to learn about naming the polynomials and then graphing the polynomials. So degree refers to a term's variable exponent, or exponent to the variable. All right, so if I've got like 3x to the third, that would be the degree of this term right here. If I have multiple terms, then it's the biggest degree, okay? So the biggest degree. When we're talking about naming them, we have special names up to a 4th degree. A 5th degree also has a special name. It's quartic, but we're just going to focus on giving names to the first 4. When you have a degree of 0, that means that you just have a constant. You don't have a variable, and that's because the degree of the variable is 0, because anything raised to the 0 power is 1, and then if I replaced it with a 1, I would just get my number, right? So we say that that has a degree of 0, okay? So the exponent to our variable was a 0. Linear functions, those are when the biggest degree is 1. Quadratic, your biggest degree would be 2. We just finished doing a bunch of those. Cubic, your biggest degree would be 3, and quartic, your degree would be 4. When you have a degree that you can't name, like let's say the biggest power I have is a 5, then we would just say that that is a polynomial, a 5th degree. I'm going to say 5th degree. Or if it's 6, it would be a 6th degree, a 7th degree. So you use the special name until you don't have a special name, and then you just put in whatever number it is. So the definition of a polynomial function is that it has exponents that are whole numbers. And when we talk about exponents, I'm talking about the exponents of your variable. Okay, so exponents of your x. They have to be a whole number. What are whole numbers? What are whole numbers? What do they start with? That's natural numbers. Whole numbers start with 0, 1, 2, 3. So no negative numbers, right? No fractions, decimals, anything like that. The coefficients, which are all the numbers in front of your variables, those have to be real numbers. So we can't have any i's, right? Everything should be a real number. All right, so the first part of naming a polynomial is learning about the degree. The second part of it is stating how many terms you have. So if we only have one term, what is the name for that? Let me start with an easier one. What do we call something that just has 2 terms? A binomial. So what do you call something that has 3 terms? A trinomial. So what's something with 1 term? Is that what you said, JC? A monomial. Mono means 1, right? Poly means many. All right, so we don't have a special name for a polynomial with 4 terms. So if I have anything bigger than 3, so let's say I have 4 terms, I would just call that a polynomial with 4 terms. So if I did 5 terms, it would be a polynomial with 5 terms. So we are going to decide whether each function is a polynomial. If it is, we're going to make sure we write it in standard form. So standard form is when all of my degrees go from biggest to smallest. So like if I had x to the 8th plus x to the, that's x to the 7th plus x to the 10th, I would want that to go biggest degree to the smallest. So this one would need to move up front. So you're literally just going 10, 8, 7, like you just want to go biggest to smallest. All right, so if you look at number 1A, I'm going to look at this, and first I'm going to decide if it actually is a polynomial function. So I look at my numbers in front of the variables. So I have a -2, a 5, and an 8. Are all of those real numbers? Yes. Then I'm going to look at my degrees. I have a degree of 3, a degree of 1, and a degree of 0. Are all of those whole numbers? Yes. So this is a polynomial function. And then I'm going to check to make sure I'm in standard form. So do my degrees go down from biggest to smallest? Yes. So now I'm going to name it. So first part is you look at your degree. Your degree is the biggest one, which is 3. What's the special name for a third degree? No, a third degree. Cubic. Right? And then you tell me how many terms you have. So you have 1, 2, 3 terms, and we have a special name for that, which is trinomial. So that is a cubic trinomial. So if you want to make yourself a note, the first part has to do with your degree. The second part has to do with number of terms. So if you have a special name for the number of terms that you have, then you should put that there. If you don't, then you would just say that 5 terms, polynomial with 5 terms, right? All right, part B. So look at your coefficients. I've got a -0.8, a square root of 2, and a -12. Are all of those real? Yes. We have no i's, correct? And the square root of 2, it's not rational, but it's a real number, right? So then I'm going to look at my degrees, and I'm going to say, okay, I have a degree of 3, and a degree of 4, and a degree of 0. Are those in order? No. So I'm going to move the term that has the degree of 4 to the front. So I have square root of 2x to the 4th. After that, I would need the one that is the degree of 3, so -0.8x to the 3rd, and then my -12 at the back. So now that I've ordered it, what's the degree of this polynomial? 4. Do we have a special name for a 4th degree? Quartic, right? All right, so it's a quartic. And then how many terms do you have? We have 3 terms, and that's called a trinomial. So part C, look at your numbers in the front. You have -1, 7, and 4. Are those all real? Yes. Look at your exponents. You have 2, -1, and then 1. Are those all whole numbers? No. So therefore, this is not a polynomial function. All right, and the last one. We're in order, yes. I mean, even though we don't know what this is. Your degrees are the leading coefficients are 1 and 3. Are those real? Yes. Are your exponents whole numbers? Do we know? No, because this could be a -2. I don't know what it is, right? So since this can represent any number, it is also not a polynomial function. I actually have to have a number up there. All right, and I'm going to add a couple more down here. I'm already going to put these in order, though. Just know they are polynomial functions. We're just going to practice the degree part. So in part E, first thing we want to do is look at your leading coefficients. You've got 1, 1, 1, -2. Are those real numbers? Yes. And then all of our exponents are whole numbers, right? So my degree is 7. So what do we call something that has a degree of 7? A 7th degree. And what do we call a polynomial that has 4 terms? Polynomial with 4 terms. There we go. We just call it a polynomial with 4 terms. So this is a 7th degree polynomial with 4 terms. Because we don't have special names for any of that, right? So if you look at part F, what degree is this? 8. And do we have a special name for an 8th degree? Okay, so you would just say an 8th degree. And then you have how many terms? 2. What do we call that? Binomial. Okay, so when we talk about our end behavior, we're talking about what's happening on either side of our equation. So if we have an odd degree, then I'm going to have a section that's going down and a section that's going up. Or it might go up and then be going down. Depending on whether that is positive or negative in the front, your leading coefficient, if it's positive, then you will end on a high note. And if it is negative, you will end on a low note. And you can also think of this like slope. Like that's a positive slope, right? And that's a negative slope. All right, if the degree is even, then you're either going to be going both up or both down. If out in front your leading coefficient is positive, then they are both going up. If the leading coefficient is negative, then they are both going down. So on number 2, we're describing this. So you have the same statement every single time. The only thing that's different is your infinities. All right, so I always say that f of x is going to be approaching something. This little symbol right here means approaching. So leave a little spot right here for you to put an infinity sign. As x approaches a positive or a negative infinity, we'll fill that in. And you have 2 sides, so you need 2 statements. So we're just going to write that down twice, and then we're going to fill in the infinity. So if we want to know what's happening, we need to look at our degree and our leading coefficient. So I'm going to put a D here for degree. Degree is your biggest degreed term, which in this case is 4. And 4 is what kind of number? 4 is even. So that means either both sides are going to be going up or both sides are going to be going down because it's even, right? Then I'm going to look up front at my leading coefficient. That would be the number that's in front of that degreed term. Should be in the front if you're in standard form. So that is negative 0.5. So since my leading coefficient is negative, that means that both of my arrows will be going down. So just to reiterate, my degree is even, so I'm either both up or both down. And I'm negative out here in front, so that means both of them are going to be going down. So I'm going to do the x first. So when I say as x approaches, when I say left side, I'm talking about the left side. If I say the right side, I'm talking about the right side. So this would be the positive side, and this would be the negative side. So let's start with x approaching negative infinity, so on this side of my graph. If my x is going this direction, what's my y value doing? It's going down, so that would be negative infinity. And if you want to just think of this as the graph goes down, negative infinity. All right, but if I'm going this direction to the right towards positive infinity, so my x is going towards positive infinity, what's the graph doing on this side? It's going down. So my y is approaching negative infinity, and then bam, you're done. So here's something else to think about. The x value is always going left or it's going right. And then you just adjust what the y is doing. So if on the negative side I'm going down, that's negative. If on the right side I'm going down, right side, negative. Okay, so what if this one would have been up like this? Then on the left side we would have had a positive because we were going up, right? I'm going to erase that so you're not wondering what that is. Okay, so let's look at number 3. Degree. What's the degree of this? The degree is 3, and 3 is odd. So that means that we're either an up and a down, or a down and an up, right? So I'm going to look at that number in the front, the 0.25. That's my leading coefficient. That is a positive number. So therefore, I'm going to end on a high note, right? So that means I'm ending going up. So the one on the right. So I'm going to write down my two statements. I already know they're exactly the same. So f of x is going to approach something as x approaches something. And then same thing for the other side of my graph. F of x approaches something as x approaches something. So on the left side, that means you're talking about this part, right? So that would be when x goes towards negative infinity, the left side of your graph. Your graph is going which direction? Down, so that would be negative infinity. Now we're talking about the right side, or the positive side of your graph, right? As your x value approaches the positive infinity, your graph is going up. So that would be positive infinity. These stay the same every single time. So if you wanted to go ahead and do negative infinity and positive infinity, and then all you have to do is say, okay, on the left side, on the right side, am I going down? Am I going up? Then do that. And then I accidentally left number 4 on here, so let's just talk about it. So the degree was odd, right? Which means I'm going to have an up and a down. I look up front and it's negative, so I'm going to end on a negative note. So it'll be up and then down. That means that on the left side, so when x is going towards negative infinity, my graph will be going up. So the y values are going towards positive infinity. On the right-hand side, as my x approaches positive infinity, my graph's going down. So my y value would be negative infinity. All right? On this one, degree was even, so both up, both down. In front, you had a positive, so they're both going to be up. So on the left-hand side, you're looking at this one, right? So as your x values go towards negative infinity, your graph is going up. So your y values are going towards positive infinity. On the right-hand side of your graph, when you're going towards positive infinity, your y values are going up towards positive infinity. Okay. So when we're graphing these, we're going to use the calculator to help us, but I do want to go ahead and decide what our graph is going to kind of look like. That way when you graph it, you'll know if you're, at least on the right track here. So first things first, let's do your degree. So your degree is 3, and 3 is odd, which means you're either going to have an up and down or down and up, right? You're going to end on opposite spectrums. All right, and then your leading coefficient, which is the number in front of that, is a -1. So your leading coefficient is negative. That means you're going to end on a negative note, right? Which means you'll start up high and end down low. So when you graph these, if you ended up so something like this, that wouldn't, something's wrong, right? Maybe either you were wrong here or you left something off, okay? So We are going to put this in our calculator. And mine is all messed up. So I'm going to fix that. All right, so once we get that on our y equals, right, when I press graph, you can see that I have my table and my graph on the same screen. If you want that on the same screen, you're just going to go to Mode. And down here where it says Full Horizontal Graph Table, you're going to choose Graph Table and press Enter. And then you'll have your table and graph on the same screen. All right, something else just to remind you is that like right now my table is choosing its own values to plug in for x. I can't put anything of my own in. If I wanted to put my own x values in, I would have to go to the table setup menu, which is second window, and I would have to change that to ask, right? I don't want you to change it to ask, but if you change it to ask, then over here you won't have anything. I can pick my own numbers to plug in, okay? But for now, leave it as auto is fine. Okay, another important thing is right now I'm on the graph, but if I want to maybe scroll through my table, I still have to click second graph to access the table, and now I'm in the table. See how that's highlighted in black? So I know that I can scroll up and down. Also, when you scroll through your table, it will show you where that point is on your graph. So as I scroll down my table, my little spider dude moves. Okay, so here's the thing. You can kind of see the points that are not going to be on your graph. For instance, negative 324. I can't see that, right, because it's way up here. All right, so I only want you to plot the points that you can fit onto your graph. Now, if it's just a couple above, like for instance, 3, negative 12, that's just a couple below, right? That's easy to extend your graph and put that on there. And that's actually needed because if I plot the point 2, negative 1, I can't speak, that doesn't give me a good representation of where I should extend my graph, right? If I have that extra point down there, then I'm good. So I do like this feature, though, because then you can make sure that you've plotted your point in the correct location, all right? Other important things to look at would be where your graph curves, because you're going to need to know that. Notice they are not curving on an exact, crosshairs point. So you'll need to make sure that you, kind of eyeball that when you're graphing them. So I want you to write down the part of the table that you can actually graph. So I'm not going to put negative 324 on my written table because I can't graph that point. So I'm going to go all the way from negative 2 down to 3, and I'm going to write that down. So you're just going to plot these points. So negative 2, 3, negative 1, negative 4, 0, negative 3, 2, negative 1, oh, and then 3, negative 12. So these are kind of like my guiding dots, right? Now, I still need to pay attention to where I curve. So if you wanted to put like a dot maybe where it was curving, that might be a thing for you to do. So it's kind of hard to see. By the way, I want to get back on my graph, so I'm going to press graph. It's kind of hard to see where this is curving, right? Because it's not very zoomed in. If you want to zoom in on it so you can kind of get a better picture, just press zoom and choose zoom in. Now, it doesn't zoom in right off the bat. Notice it gives you this little blinky thing. This little blinky thing right here is saying where do you want to zoom in at. So, for instance, let's say I wanted to get a little closer down here and have it zoom in on that part down there. I'm just going to go down there and press enter and see how it kind of scoots my graph right there. So it looks like this is negative 3 and negative 4. It's curving right there, right? So I might want to put a little dot in between my 0 and my negative 1, about 3/4 of the way over. So between my 0 and a little 3/4, so maybe right there. And then the other one is about right here. So you might want to put a dot there. That way when you draw this in, you'll be able to kind of curve right there and curve right there and not have to kind of guess. So now you're literally just going to draw in, and this is going to be awful because I'm drawing on my Moby here, and connect these dots in that shape. I'm hoping you guys looks better since you're actually on paper. And put your arrows, and I do want to point out, see how we were up on the left and down on the right?